Alright, the final piece of this chapter is just to review a topic which, you should be familiar with, but we need to review it at least for a few minutes because it's extraordinarily important when it comes to organic chemistry. And it's especially important when it comes to organic mechanisms, because often this is what determines whether a reaction proceeds or not. Or in another way, it's often what determines how well a reaction proceeds, because oftentimes we'll see and we'll talk about in a mechanism there might be 3 or 4 steps where they're not very favorable, but one step manages to pull the reaction forward. So for many reactions, and so what we're going to be talking about here is everyone's favorite topic, equilibrium. So for many reactions, the equilibrium constant is so high that the reaction only goes in one direction. For example, if you take an alkene such as ethylene and add HBr to it, you'll form bromoethane, and the equilibrium constant here is 7.1 times 10 to the 7th. So this equilibrium is so high that we basically say this reaction goes to completion. And that's because for every $71 million molecules that go to product, we have 1 molecule of each of the starting materials left, approximately. So yes, even at equilibrium for something this good, there's still a little bit of starting material left. But again, if we're talking about 1 in 71 million, that's not really noticeable in just about every circumstance. But if we look at a reaction which we'll learn about later on, known as the Fischer esterification, this takes a carboxylic acid and an alcohol and converts them to an ester while kicking out water as the byproduct. How's the equilibrium on this reaction? Well, the equilibrium on this reaction is 3.38. What does that mean for us? Well, it means that this is a reaction that's going to favor the products, but not by very much. In fact, we could ask the question, if we had 1 mole of the acid and 1 mole of the alcohol and we started with none of the products, how much product would we form at equilibrium based on this equilibrium constant? Well, we can write an equilibrium expression which is the concentration of the ester times the concentration of the water divided by the carboxylic acid times the alcohol. Now, how do we find those numbers? Everyone loves an ice table, right? So we know that the carboxylic acid goes down by some amount. Since they're 1-to-1, the alcohol goes down by that same amount, and the ester and water will go up by those same amounts. So we can plug in our equilibrium values. Like that. And then we can expand. So we get x squared over x squared minus 2x plus 1. And then we can simplify. 2.38 x squared minus 6.76x plus 3.38 is equal to 0. And now we just have to solve for x. Well, how do we do that? Well, hopefully at this point you all remember your quadratic formula, because that's what you're going to need here. And we get two possible values. X is equal to 2.19 or 0.65. Which one do we choose? Well, with 2.19, if you recall, our concentrations are 1 minus x. So if we take this 2.19 and try and plug that in here, that would mean we ended up with a negative concentration. So what we really need is the 0.65. And so if we fill that in here, what this tells us is that for this reaction with an equilibrium constant of 3.38, no matter what we do, only about 65% of the starting materials can be converted to product. So in this class, we're not typically going to be doing a lot of calculations like this, or really any calculations like this. But we need to keep these principles in mind, because it's, what would we do in a case like this? So 65% as a maximum yield is pretty terrible. What would we do here? Well, what we would need to focus on is ways to make it better. Things like, as the water forms, maybe you can remove it from your reaction mixture. If you do, that pushes your reaction to the right. Maybe we have ethanol here, maybe we use that as our solvent. That way there's a lot of it. Pushes our equilibrium to the right. And so if you've forgotten Le Chatelier's principle, make sure you spend some time reviewing that. Le Chatelier's principle, which is what we're talking about here at the end, the way that we influence an equilibrium, is something that we're going to see applied over and over and over again in reaction mechanisms. So that's the end of this chapter, which is our introduction to mechanisms. And from here, we will start into alkenes.